Hello, I'm Rick Baldwin. I'm a professor, I'm a professional engineer and a professor in the Mechanical Engineering Technology Technician program here at Niagara College. I'm going to take you on a tour of our labs here at the Welling campus, but before that I want to talk about the program a little bit. So there's a technician program, which is a 2-year program, and the technology program, which is longer, a little over 3 years. And the reason it's that long is because we have 16 months of co-op built within the program. Students in the technology program will receive 2 8-month co-op terms. Our co-op placement is very high, over 95%. Virtually all students get co-op jobs who've applied. And our graduation placement is fantastic. Our students are all employed, working in the area. About 75 to 80% of our co-op placements are within the Niagara region, but we have had students with placements in Brazil. We have had students with placements all over Canada. So I do want to show you a little bit about the program. So here we have, it's a laptop program. So first of all, I want to start with the Technology Technician program. It's a laptop-driven program. You are issued a Niagara College laptop within the price of tuition, within the cost that you pay the college, you receive this laptop. The beauty of that is all students have the laptop and they have all the software loaded, software like Inventor, PLC programming software, ABB Robot Studio, all of this very expensive software which can has a value of in the neighborhood of $60,000 to $80,000 is loaded on the laptop, and all students have the same. This way you're not stuck working in a lab. You can then take the laptop home with you and you can do work at home. You bring the laptop to class and we do everything still by hand, still on paper, but also use the tools that are available. And so we use the latest technology and we always have the most current software. And the software we use is industry standard. So when you go to industry, you will see the exact same software on the laptop. In industry, you'll be using the exact same software. The program has a few sides of it. Oh, here is a model, a log splitter designed by a senior student. And within the program, there's a heavy design component. The design component, you do full stress strain analysis, 3D modeling, 3D printing. As you can see, we have a 3D printer here. I'll talk about 3D printers in a minute. But this is the model of one of the students' log splitters. This is a complete design of a log splitter that includes all the purchase components, stress analysis, weld design, and by the end, you create this design package that you can manufacture this log splitter from the student's design. So there's a heavy design component within it. I'm going to take you through the labs, which are more of the hands-on components of the program. So this is our computer integrated manufacturing cell. I'm going to go through some individual components within this cell first and then show you how it all gets integrated. So here we have a robot. You can see the cage, steel cage, which is industry standard, very safe. You cannot get injured in this system. Safety is a #1 protocol here. We have e-stop buttons located close by. We also see light curtains here. So these are light curtains to prevent people from entering when the robot is powered up. You have the ABB industrial robot. It's a smaller one, but it's the exact same robot you would use in industry, and a Cognex vision system that we can integrate with it. So students will spend time simulating the robot on their laptop, creating a simulated environment, testing their programs, and then coming in here and actually trying it out. We also have pendants that allow them to manually teach the robot like you would do in industry. So here is a pendant that an operator would use with 2 hands to teach the robot the various points to allow it to operate. That's one aspect of the manufacturing cell here. Another aspect of our manufacturing cell is the CNC machines, and we have a number of CNC machines. We have CNC lathes. So this is a CNC lathe with a tool changer, fully automatic, runs off a Fanuc programmer. So students will spend time programming the actual CNC lathes, manual programming CNC, using Mastercam as well, and then actually cutting parts. And they actually get hands-on to get that experience of what it feels like to make chips, what the machine sounds like, what they actually see, what chips look like. So we have CNC lathes that the students will spend time on. We also have CNC mills. So here's an example of a mill, Tormac PCNC 440, and a mill with a tool changer built into it. Sorry. Mills are powered down right now so I can safely open the guards. There is a tool changer built in, work holding device within the machine. and some small tools here. And again, they have that exact same experience where you spend time on the machine, manually programming it, and then generating chips. Over here, within our computer integrated manufacturing cell, we actually have the robots connected to the conveyor system, connected to the CNC lathe. So if you look over here, we have a lathe. Here is the robot vision system, a conveyor there that would transport parts. And once you've learned all these individual pieces, including some PLCs that I'm going to show you later, and you've learned how to program all these individual devices, you now make it integrated into a manufacturing cell where you are picking parts up off the conveyor, loading them into machines, unloading from machines, using a vision system to check, and creating a fully integrated, computer integrated manufacturing cell as you would see in industry. Here we have our Allen Bradley PLC. Once you've learned to program PLCs, then when you come into this computer integrated manufacturing lab, you then integrate it. This PLC controls the conveyor system, communicates with the robots, and communicates with the CNC machines to drive this entire system. Here we have the human-machine interface device, which you will program as well to allow the operator to interact with all the devices on this assembly system. So here we have 3D printers. This is an Ultimaker desktop 3D printer. We have a number of these that students have access to. So when you've created your 3D model, students actually do work as a team and create some 3D printed models of die sets and different industry components. We also have over here some industrial printers. These are more industrial level 3D printers that can do more exotic materials with fair-sized work envelopes. And so students will have access to these as well if they need to use some more exotic materials. In our research division, we actually have larger printers that can be used for even more advanced aerospace materials. And some students have access to those as well. Okay, so welcome to our metrology lab. In here, we study the science of measuring. Basically, we have a small lab. The lab has workbenches for the students. The students typically work in pairs here. This lab will accommodate maximum 20 people. And each station has its own granite table. And we have cabinets there full of different gauges. Here's some samples of an indicator gauge. And so the students can actually learn how to use the tools of measuring, and actually apply it at the workbench. So we will have instruction going on, and then interactive activities where the students actually measure components to an engineering spec, to a drawing, to see if they comply. Over here, we have a CMM. So that's all manual measurements. Here we have an automatic CMM, and this is a brand new CMM, about 1 year old, which is now in the program. We had an older version that we've now upgraded, and students will learn PC-DEMUS. They will actually learn programming, and they will get a chance to actually spend time on the CMM programming for automatic measurement of components. This equipment is used in our fluid power training. So within this lab, we have a learning environment. We have a section over there with a computer and some desks for the students who will learn lessons. They'll spend about half an hour to an hour in a lesson activity, learning a bit about hydraulics. And then typically they come over to these workstations. Here we have 6 workstations where students work in pairs. So a maximum of 12 students within this lab at any one time. And they'll work at pairs here, either creating the circuit that they've designed, or creating a circuit that's already been sketched once they've learned what all these components are, how to read a drawing, and how that matches up to the components that are on the workbench here. As well, sometimes there'll be a circuit already hooked up that they can then troubleshoot and try and figure out what's wrong and why it's not performing the way they expect. And so they'll spend within that 2-hour lab about half an hour to 45 minutes in an activity learning, and then the balance of that time will be spent here at the workbench, studying the system, the mechanics of the system, and how it physically interconnects. And so we're still in the fluid power lab, and this is our pneumatic benches. So here we have, very similar to the hydraulic system over there, we have a pneumatic bench here. Again, 6 workstations, 2 students per station, who can design their own pneumatic circuits, connect them up, see how they perform, troubleshoot when there are problems, and understand what are all the components in a hydraulic system, and how does it perform. This is one of our PLC trainers. Again, we have 5 PLC trainers in this lab. 2 students. The 2 students typically work in pairs on the PLC trainers. This is an Allen Bradley industrial level PLC. Students have simulation software on their laptops that they actually learn how to program PLCs. simulate it on their laptops, and then they can try it out here by hooking up. They can see what the different inputs and outputs are like, how mechanical motors behave with actual switches and buttons. So it's mimicking the simulated environment, but now it's in the real world, practical components that are hooked up, and they can see how it behaves in the physical real world. So I just want to thank you for coming on a tour of the Mechanical Engineering Technology Labs with me at the Niagara College Welland campus. Hopefully I get to see you here in the fall. Thank you.